away like this, people can't hear you. If you do this and you're like, people can't hear you. Keep the mic in front of your mouth, please. Also closer, like I wasn't doing over there. So this doesn't really help. It's got to be upright like this. You can just do like, you know. All right, it's working. Okay, so back down to the seat. Oh, and feel free to take the mic out of the stand. Okay, as I was saying, be nice to other people. Imagine that they're trying to do the same thing you are, which is make the internet better. Please don't make us have to say this again. Okay, and then after that, Warren has some intro stuff. Unless somebody else has other agenda items they'd like to hop to the mic. Maybe it's not working again. Well, I mean, audio is working, video. Do we have to dance now, George, to keep the... Okay. Okay. Audio, video. We have both the A and the V.
My God, you're tall. There we go. So hopefully audio and video continue to work for a little bit. Actually, hopefully they continue to work for the whole thing. So hi everyone, I'm Warren Kamari. I'm the Ops AD and have been AD for this working group for what feels like a very long time. I am still enjoying being Ops AD, but my term is up in March. And I will probably run again, but what I would really, really like is for a bunch of other people to run. And so if anybody's interested in knowing what the Ops AD role is like, what the time investment is, what the fun parts are, what the less fun parts are, please come along and talk to me, and I'm happy to provide background, chat about what it's actually like, etc. As I say, I've been doing it for a while, and I've been doing it for a while because it's actually kind of fun. Some parts more so than others, but yep, as I say, come hunt me down, let's have a chat. Happy to provide any background, etc. And Natalie, does it still seem like audio is working? Yay!
Okay. Oh, my presentation got kicked. Nope, saw all this stuff. Saw Warren. Too far. Okay, I think the next person up is Igor, who was here. Oh, still here. Excellent. I think you don't have a phone with you, so I can do the slide clicky-clicks.
Can you just drive the slides and
That's, yeah, exactly. I can do
Okay.
that as soon as I find the slides. It's PA.
Well, I'll introduce myself first while the slides are coming up, and they're here. So I'm Igor Lubashev. This is something that Sriram, Doug, and myself have been working on. Sriram is in India, but he is virtually with us. So this is something that a problem space that's typically not been worked in Sidrops, and maybe that's why it's still a problem. So we're trying to bring it to this group because we think that Sidrops have some very unique and interesting techniques that can help. So next slide. So the problem is source address validation on the internet, or basically how do we stop bad people from spoofing IP addresses and doing bad things. Problem is not new, been around, well, been around forever. In 2000, we even had a draft that says that's bad, should fix it. We're in 2022, still working on this problem. The best we've got, state of the art, is look at BGP messages, insert some information from it. The algorithms that we have don't work other than in theory, because real networks, I mean, the algorithms require no route filtering, no real traffic engineering that can happen. Well, that's not real world. So the feasible path RPF that's been with us from 2004. Yeah. 2 years ago, there's been an improvement, 8704, which basically said, hey, let's look at those BGP update messages one more time. There is a little bit more information we can infer, which is origin AS number. So if you find on the interface some route advertised by that origin AS, look at all your BGP announcements, and any route advertised by that, any prefix advertised by that origin AS should probably also be okay. And there is also one small paragraph in the draft, like really an afterthought, and talking to the author of it, it really is an afterthought, that says you could also look at raw information and maybe augment your data set with that info. But anyway, it's much better, but still has a bunch of problems, and here we are today. Next. So this is a simple, very simple example why 8704 is not working. You have AS1, which is a customer of AS2. AS2 is multi-homed, and it propagates customer route to both providers, but its own route it only wants to propagate to AS3 for reasons. If AS4 is doing source address validation, AS4 will not see any prefix advertised with AS2's prefix 2 on its customer interface, and therefore it will not accept packets from prefix 2. So 22 years later, people are really trying to fix it. Why are we still having a problem? And we contend that the root cause of it is that we're trying to infer data plane forward information from BGP signal that was not designed for it. So it just doesn't have enough signal. The next idea is, well, we have other sources of authoritative information. So for example, raw, and well, we're talking about ASPA. And somebody also suggested earlier this week, what about signed IIR data? And actually, why not? So again, that's also signals that were not designed for source address validation, so also hacks, but that's what we do in the internet. We try to do hacks that work. So that's why we're here and trying to see what we can do with raw and ASPA. But next, before we go a little bit further, next slide. Just first of all, apologize for this slide. It's a little, it has a lot more graphics that we're used to at IETF. I just pulled it from an internal presentation. But it's basically a real problem that I'm very familiar with because, well, it's a CDN that's trying to serve traffic on an anycast IP address. And the anycast, well, I call it anycast home pub will look at the incoming request and decide there is an edge pub that's better suited to serve the traffic from. So it will tunnel some sort of AP and AP thing, the packets to the edge, and the edge wants to reply directly. And that's where the bulk of the transfer is happening. So the only thing that's taking the detour through the anycast address is the headers and the X. The heavy duty stuff is going direct. Pretty neat infrastructure. Next. So this is a more typical picture of the same thing. Doesn't have to be anycast, it's like any sort of DSR, direct server return. Prefix 4 has a customer who is contacting service at prefix 3, which is advertised, which happens to land in AS1, which tunnels the packet to AS2, the edge, and there it needs to, AS2 wants to complete the connection, but it needs to source packets from the prefix 3, so that the end user sees normal connection happening. And the question is, will AS9, its provider, allow such packets? And DSR is obviously a case, it's an important case. CDN I just described, and so is mobile roaming and some gaming and security products, whatnot. Many of the services use DSR or want to use DSR. Next. So here is a crux of our proposal. We call it BAR-SEV. BAR-SEV, so BAR for BGP, we're still using BGP messages. We need to get information from there, but we also augment it with ASPA and RAW. It is strictly an improvement on 8704, even in the way it just processes BGP messages. So 8704 just looked at the origin AS number, and BAR-SEV is looking at the entire AS path. And we'll see how it does it, but it basically gets more signal from existing messages. But it also augments its information with ASPA and RAW. The good thing that we think it's actually valuable is that it requires no new protocol, no new changes to existing protocols. Oh, that's nice. Can we get the slides back at some point? And thank you. And the fact that it requires none of that means that it's actually good for adoption, because the very, very first network that deploys something like that will immediately see benefits. So that's what you want to see, is that early adopters actually get value. Next. This is a little busy slide, many circles, but the point here is only simple one, that the protocol works on both peer links and customer links exactly the same way. Next. Now, this is a high-level description of the protocol. This is a simplified version in the utopian world where everybody has adopted ASPA and RAW, and we have the entire internet there. I mean, of course, it's way, way in the future, but I mean, basically the way it works is that you have two phases. Phase number one, use ASPA information to discover customer cone. So all the customers of all of your customers and their customers transitively. And once you have the customer cone, which is a list of AS numbers, look at raw information and find the prefixes that they've advertised, that they own. Those are the prefixes that are allowed on the interface. Next. So let's get back to the real world. Thank you. The real world is very, very similar. It's still exactly those two phases. Find the customer cone, and once you did, find the prefixes that those customers own. To find the customer cone, what you do is you look at ASPA when available, and also look at BGP AS path. And those can be received from anywhere. This customer interface, other customer interface, transits, even provider. And look at the AS path. Consider every single AS number in there, and the previous one is a customer of the next one. So look at the AS path, look at ASPA, do it iteratively until you can discover nothing new. That's your customer cone, and then look at RAW, and also look at, just like 8704, prefixes announced through BGP, and of all the prefixes announced through BGP where origin AS is in your customer cone. And that's your list for validation. Next. Next. So next. So very busy slide. The point here is not to read it, but in detail. But this is just an example where you have a bunch of different things happening. You have some prefixes that have RAW, some that don't, some prefixes that have ASPA, some that don't. There is a lot of traffic engineering, like no exports happening, things like that. Next. And the point is just to illustrate quickly how BAR-SEV works with something like this. So next slide. So first, we start with the only AS number we know, which is the AS number on the other side of the interface that we're looking at. So that's AS3. And, well, there is nothing in ASPA that shows AS3 as a provider, fine. But there is a bunch of BGP prefixes we have that have AS3, so collect everybody before it, and that's the new AS numbers you discovered. Next path, next iteration, repeat. Now we found something in ASPA and in AS path, repeat. Okay, we found nothing new. We have a customer cone list. Next. For each one in the customer cone, look at row and look at BGP announcements, which one is the one that features that AS number as origin AS. You merge the two lists together, and you have your sub-filter. Yeah, next. Yeah, I'll tell you. Two more. Okay, that's your sub-list at the end. Next. All right, if we go back at the example we had before that 8704 couldn't deal with, BARSAV deals with it trivially. In fact, it discovers that AS2 is part of its customer cone in a trivial way. It doesn't have to be directly connected. It could be like another network between AS2 and AS4, doesn't matter. It will discover it, and then it will see that there is a route received from the peer that shows AS2 as the origin AS, and prefix 2 will be accepted. Wow, we have a good... all right, so imagine my DSR slide while it's been found now. What can BARSAV help with DSR? Well, it's actually pretty simple. All you need is that the CDN owns both the edge AS number and the Anycast home AS number. CDN owns all the prefixes. Next, two more times. Yeah, good. Good. So CDN, yeah, good. Thank you. CDN owns prefix 1, prefix 2, and prefix 3. So all it needs to do is needs to publish row that says AS2 owns authorized to advertise prefix 2 and prefix 3. Now AS2, the edge one, will never want to actually advertise prefix 3. But that's okay, doesn't matter. It owns it, so it publishes row, and therefore AS9, when it does BARSAV, will find from row that AS2 owns prefix 3, and it will allow. Next. ASPA obviously can also help with route leaks. I mean, that's what it was designed for. It also helps BARSAV in the same way that when it's trying to infer information from BGP, so in this case we have AS2 that's leaked route from its peer, and the red one, and somehow that route made it to AS4. Now that route should really be rejected for forwarding, because ASPA says that it's leaked, but it made it to AS4 somehow. BARSAV, before it tries to infer information from BGP AS path, would check that, hey, I'm thinking of adding AS8 as a customer of AS2 because it comes after AS2, but AS8 actually has a ASPA entry, and AS2 is not its transit. So it will reject adding this AS8. However, we say that it will reject, but it can still infer that AS2 is a customer of AS9. No reason to do that. And in fact, if it's needed, it will never be actually needed in this case, but AS5 is a customer of AS8. So basically, ASPA validation also helps Barsev to construct a correct list. Next. And actually, I want to do one more slide, just one more, that will be my last slide, just to show that this problem is important and this problem is not being solved on the internet. In 2015, we've looked at Akamai, we've looked at several thousand of our POPs where we are and to see how many of them do any sort of source address validation. And we found that about 15% did. And just before coming here, I pulled the stats, and in 7 years later, about 15% of the networks do source address validation. So I don't think it's purely economics. It's mostly like it actually is not working too well, the algorithms that we have. And maybe we really expect that improved algorithms with data produced by Sidrops will actually move the needle. Thank you.
Yeah, do you want me to go there?
No, I said, go to the mic, please, for questions.
I can probably jump in first. Keyur Patel, speaking as a working group member. I think it's a great presentation. 2 points I will make is that it'll be great to see how this solution solves the problem for IBGP cases while you have depicted eBGP cases. Most of the problems will probably also require you to have a control within eBGP. It's quite possible in this scenarios that across IBGP, a solution may not be honored or may not be enforced. But what is critical is if we can sort of zoom into IBGP cases, that would be phenomenal. Yeah, thank you.
Thank you. That's it is. I think it's very valuable to also look at IBGP. One of the things that we want to do is that on the internet is that okay, if one network will not enforce it, maybe the next network should have a chance to still do it. That said, obviously, all this SEV filtering best done as close as possible. But that's a good point.
Okay, since the chair seems to be distracted, Jeff Haas. I worked with Sri Ram and Doug on 8704. I'm going to offer 2 observations for you that feed on the stuff from 8704. The core enhancement from 8704 is one part, you can add stuff to your source address validation from additional BGP data that's not being used immediately for forwarding. So being able to seed it from other sources is great. You know, the presentation you're giving is an excellent example of that. We talked about ROAS as one example in 8704. I'm glad to see this is going forward. But the second thing ties into the slide you're displaying here about the economics. You know, it's like, why haven't we seen more of this stuff? It's one part, the tooling for adding 8704 is not out there. But the bigger one is source address validation in hardware is predicated on burning FIB resources to do the extra lookup to see if, you know, that you can actually do this source address validation. It's cheaper than doing firewalling. So from that perspective, it's a wonderful thing. But it's still an additional cost in your FIB in cases where you can have SAV covered by what you're using for forwarding. You basically get it for free, just at the cost of additional forwarding lookups. Yes. Every other thing that we're looking at here, and as you start expanding these use cases, you're looking at it effectively, you know, doubling or tripling the size of your FIB to be able to implement this functionality. So part of what you're fighting against is the economic cost of something that's there for security that isn't actually selling moving bits around. It's actually to help you stop moving bits. Thanks.
So thank you. That's definitely, I mean, that's part of the point I'm making here, that economics is definitely a driver, probably more for some networks than the others. Some networks would actually benefit. And I mean, we do see that 15% of the networks chose to implement something. So there is some value there. So, but anything we do is important that, yes, it's as economical as possible, especially for the smaller networks, because that's where the source address validation is done best, and especially for the first movers.
Hi, Ben Madison, Work Online. So there's three separate things. Firstly, just to kind of continue from the point that Jeff was making. Certainly all of that's true, but one caveat to that is, at least speaking for the network that I operate, we typically run out of faceplate interfaces long before we run out of packets per second. So that interaction with the hardware is not necessarily a deal breaker, even for reasonably large networks that are kind of a similar sort of a shape. The second point I wanted to make is mostly to just reiterate what I mentioned in SAVNet, which is that using RPKI objects in this way kind of breaks the fail open semantics that they have in their current use case, and I think we need to think quite hard about that. I think there are other use cases where we want something that's kind of like a sticky RPKI object. I think that's going to be required if we ever want to replace things like the IRR. So I think that there's other work, other useful work that would need the same sort of thing. And then the third thing is your example of pruning the customer cone using the ASPA, I think is problematic semantically. Because I can imagine a scenario where a customer wants to use a transit link purely in the outbound direction and never intends to advertise any inbound reachability over it, and therefore doesn't include that adjacency in their ASPA, but expects the return traffic to the outbound traffic to continue working, and using it to prune the source address validation filter in that way breaks that assumption. And I think that's going to be, if we wanted to do that, I think we'd have to be very careful about how we document it, so that that doesn't end up being a nasty surprise for a knock somewhere in the world at 3 in the morning, because it's such a corner case, but it's a valid corner case. Kind of all of those cumulatively leave me kind of feeling like if we want to be using RPKI objects for source address validation, I think I would prefer looking at defining new objects with those precise semantics rather than trying to kind of shoehorn the stuff we've got already into this hole. I think it's a worthwhile thing doing potentially, and I'd be happy to, you know, spend cycles on trying to get it done, but I don't love the trying to reuse the existing object stuff.
Okay, thank you. So let me try to remember a few comments. So the comment about implementation, yes, you're absolutely right. And basically, like I said in SAVNet, I mean, the devil is in implementation. And yes, if you have a temporary loss of cache, your implementation should expect that this can happen and not start to deny a lot more. As a last comment, absolutely. Having a purpose-built signal is much less of a hack than using another signal that was not built for the purpose. So I see it as a trade-off between doing one more thing that's new versus using things that already exist. Now, ASPA doesn't really exist, so it's an opportunity. So I agree. Thank you.
I think Cohen has a question as well. He's the last person with questions, so.
Yeah, I wanted to also continue on the point that Ben Madison made, Koen van Hoven, University of Atlanta, by the way, regarding what you expect the failure condition to be, because we've seen that RPKI publication points don't meet this even 100% uptime availability. At all times, there's probably some publication point out there that isn't quite working as it should. So you're not retrieving the ROAS or in the future the ASPA objects that from there. And what I've heard from you, or what I've understood, that would mean that suddenly a lot of traffic is getting blocked, which indeed goes against the fail open nature of the RPKI. How do you, and you did answer to Ben Madison that you should take care of when your cache goes, but what if just part of your cache goes?
Right, so that's the same comment about the implementation detail, is that how can it see, I mean, the first thing that comes to mind is you cache your information, and you assume if something disappeared, it's still valid for like 24 hours or 48 hours. And only if it's still not there 48 hours later, you remove it because you think maybe it's for a reason. I mean, that's just the first thing that comes to mind. Maybe other people will come up with some more clever heuristics.
Mhm.
Okay.
Okay.
Okay. Oh. Great. Jeff? And then Alexander.
Yeah, hi, Jeff Houston. In looking through this, what I understand you're trying to do is to take the simple case of source address validation, which is a stub network where you've got enforced symmetric traffic because there's only one way out, it's a stub. And you're trying to synthesize that form of stub by taking an arbitrary subnet of networks and saying, well, what's the total amount they can sort of advertise in that arbitrary subnet, which is a closed connectivity domain. You're looking at the union of all possible source addresses. But you're using a tool, the ASPA, which is a policy-based tool that has directionality involved. You're not using a connectivity tool that doesn't care. And in my head is this lingering doubt that when you try and assemble this sort of closed connected, what you called customer cone, which is not quite correct. It's a cone of connectivity. And saying, well, all the possible source addresses are now known because of ROV, etc. Therefore, I can apply this ACL. Your implicit assumption is that the policy directionality is the same as isomorphic to straight connectivity. And somewhere in my head is a niggling doubt that I don't think that's the case. And if that is the case, there's a problem there. And I haven't heard you kind of reassure me that that's not true, or directly address this issue that policy-based connectivity is isomorphic to just straight connectivity, right?
So you're absolutely right, and that's what I've, and in fact, everything that has been done since 2000 is looking at the signals, and BGP is exactly the same thing, that have directionality and trying to infer the reverse direction. And ASPA is just another signal like that, and that is the information that we do have, and we don't have the other one right now. And so the goal is, what can we do given what we have? Because that's the only thing we can do. Well, okay, this is the only thing we can do immediately. We can build something new, absolutely. But then when we build something new, it has to have the property that it's cheap for early adopters, and early adopters get immediate value when they're the first network to adopt it. Otherwise, you get problems. And I mean, IPv6 kind of comes to mind, but let's not go there. But in your essence, absolutely right, but we think that getting ASPA information and raw information will enhance the state of the art we have and get it better. Will it get it perfect? No.
An overly restrictive view of the prefixes coming from this bounded set of networks will create filters that are too enthusiastic, that there will be valid presentations of source addresses that aren't in the list that's created. The problem with going down this path is that the operator pushback, where an otherwise perfectly valid packet gets discarded because of some automated tool, then becomes an operational cost. And that's the underlying concern when I review this work, going, you're starting from a small set that's constrained rather than a large set that's maybe overly liberal, but at least it encompasses all of that connectivity bound. And, there's more work to do here, obviously, but, it's an interesting approach, but it just struck me that policy and connectivity don't quite align the way you'd like it to for this work.
Exactly. So the goal, I mean, what this thing is doing on top of what exists is that it's trying to expand the number of prefixes that it will find to put into your more permissive list. So it's trying to get the list more permissive. Will it get it perfect? No. And there was a suggestion, how about you create a new SPA record that's specifically for it? That's maybe we could explore that. As far as the network goes, so that was like, okay, somebody put SPA just because they know that they will never advertise to a particular provider, they never listed them in SPA. Maybe now they will, because they think that this is, but maybe it's a bad idea because it goes against the original purpose of SPA. So that's why I think it should be explored, another SPA record type.
I suppose we agree this is
Yeah.
not ready yet, but it's an interesting path to take.
Well, it's the first time we bring it here, so, and if there are people interested in working on it, that it will get better.
Thank you.
Hey, one quick question, Keyur Patel again, speaking as a working group member. You talk about the customer cone and the relationships there, but isn't this problem wider than that?
Can you elaborate a bit?
Meaning the attack can also happen from a peering AS as well.
Yes. So when you're talking, when I said the algorithm works both on peering interfaces and customer interfaces, when you're looking at a peer interface, you're trying to discover their customer code.
Got it. But it's quite possible that AISP has not turned on this, and you're simply peering to that ISP, and you still have an attack, and this attack can be generated from a service provider itself, right?
Right. So this is not defending against incoming packets that coming from your service provider into your network. This is filtering packets coming from your customers or your peers. I mean, unless your service provider is giving you a full table, in which case you can really treat them as a peer.
So Ben Madison again. I think the failure mode that Claire's kind of hinting at is when you have a combination of a regionalized peering and a partial transit service offered by that peer or even to one of your own customers in a different region, then that kind of breaks this kind of closure of the allowed to originate traffic relation. And you end up not discovering potentially valid sources, even under the expanded algorithm, because those paths don't show up. I think but I don't think that's got anything to do with the RPKI related stuff here. I think that's a fundamental problem with the kind of algorithm assumptions.
There are two things there. One is if those networks actually bother to create SPA records, they would list themselves as providers. So it would discover it. And also in a particular location where somebody is a customer, you would likely receive BGP messages from them pointing to that interface. I might need to think a little more about it, but that's...
Yeah, so there's a gap there because of the fact that you don't have to talk about lateral peerings in ASPA records, that the paths don't show up in BGP because of policy. The adjacencies don't show up in the ASPA because they're just peerings, and as a result, that gets left out of the code. I'm pretty sure that there is a gap there that we wouldn't catch. It only happens in the partial transit case, but I think it would happen.
We can look at it. I think it's an interesting case that needs to be explored. Okay, thank you.
Next, we have Tom next.
Okay, you can hear me?
Yes.
Yep, okay. All right, thanks. So to recap briefly on this, this document defines a new signed object called a trust anchor key object or TAC object. And the idea is that it's used to signal to relying parties that the TA key or the root CA certificate URLs are going to change. So the main goal here is simplifying key rollover. If we wanted to roll a key today, we'd have to take our new TAL file, distribute it to all the different vendors, wait for people to upgrade their clients if they're upgrading them. The upgrade process would have to involve getting that new TAL into place, and so on. So there are a few steps involved, and a few things that can go wrong. Or clients might have a custom TA update process, maybe operating system packages or something like that. So whereas if we have a process like this, then it's all in band, and even the people who aren't updating the trust store automatically, they still get a signal that there's a change and they need to do something. So the more confidence we have in this process, the easier it is to do key rollover, and that helps with HSM vendor lock-in, which is the main goal here, not being stuck on one HSM indefinitely. And the secondary goal is the ability to update root CA certificate URLs. So that just gives us a bit more flexibility around deployment. So this was last presented at IETF 111, and one of the key feedback items was to look at other approaches to TA rollover and just see whether they might be relevant here. So one document that came up out of that was 4210, Certificate Management Protocol, which has, as part of its TA transition process, this root CA key update section. The idea there is that a TA operator, when it's transitioning to a new trust anchor, will assign the old one with the new one and the new one with the old one, and then make those certificates available via a repository that clients can, where clients can retrieve them, so that if the client trusts the old trust anchor, then they can validate stuff signed with the new trust anchor and vice versa. But there are a couple of things here which are different from RPKI. The first one is that TA distribution is out of band. Clients might be using the old one or the new one, whereas with Signtel, TA distribution is in band. And the other thing is that with CMP, or at least in that context, clients might receive certificates from other sources, whereas with RPKI, it's all in the repositories. So it's not clear that this model is applicable in the RPKI space. The next document is 8649, hash of root key certificate extension, which was mentioned as part of the discussion after 111. The idea there is that you include the hash of the upcoming TA key in the TA certificate that you distribute, so that when a client sees that new TA certificate, it can compare the key with the hash and know that this is the new certificate is using the expected key, basically. Tim commented on this at the time on the list. One issue is that RPs may not ignore that extension, which could be a problem. Another one is that if the new TA certificate replaces the old one, then there's no way to transition from previous TAL data once the certificate's been replaced, which is not ideal. It's good to have that transition available. Another thing is that 8649 involves TA certificate issued ahead of time that is presumably stable, whereas RPKI, because of the indirection of the TAL, supports arbitrary reissuance of that certificate. So if a model like this were to be adopted, there needs to be additional guidance about what to do when the value changes and so on. Web PKI, it doesn't appear that anybody does roll over here. It looks like root CA operators just issue new root CA certificates and rely on cross certification. So not dissimilar to the CMP type approach. And the last document found here was 5011, automated updates of DNSSEC TAs. So one of the key things from that document is this idea of an acceptance timer. A client sets an acceptance timer when it sees a new key, and it needs to continue seeing that new key for a period of time before it updates its trust store with that new key, starts relying on that new key. So that model has been adopted in the signed-tail document now. The acceptance time period is 30 days, which is just arbitrary. And the idea is that that will help with some of the concerns that were raised around temporary key compromise. If an attacker has access to the key even for a short period of time, they can transition everybody to a new key and a new publication point controlled exclusively by the attacker, which is, and then it's game over. So this will help with that. Something else that came up with 07 was the use of the term revoked. The attack object in 07 had this revoked flag, and when that was set, it was a signal to the clients to move to the successor key. The problem is that it's not really revoked in the sense that that term is used in other contexts, because you still have to use that attack object to get to the new key. So it's just not the right term to use. So to address that, the attack object no longer has a revoked flag, it just has a different model. And there's some advice in the document for TAs to reuse previous TA certificate URLs for new keys once they've stopped maintaining the previous key. The idea with that is that if an attacker gets access to a previous tailed key and publication point, a client that connects to that will see a different certificate with a different key, and then all things being equal, we'll go and get new tail data and everything will be fine. It won't be possible for the attacker to exploit that client. A couple of other changes. The attack object now includes a reference to the predecessor key. This is just a belt and suspenders type thing, making sure that each publication point is operating in an expected capacity. So that the successor key actually knows that it's operating as a successor for a specific predecessor. There's some discussion around the use of attack objects as a substitute for tail data. And after the cutoff, there were some further updates around security and I suppose threat model type updates, but they didn't make the deadline. So they'll go into the next update. And another thing that came up at the last time this was presented was looking at the currency of validators to see when it might be possible to rely on something like this in practice. So this is a graph of the validators that we see at APNIC's RRDP service, but probably every RRDP service sees something similar. Each of the data points on the x-axis is from the last day of that month, the validators we saw on that day. On the y-axis, we have the ASNs, and the ASNs are got from the IP address information just by looking at BGP. So the clients, or rather the relying parties that provide version information, those are RouteNator, OctoRPKI, RPKI Prover, the RIPE validator, and Fort. So each of those is taken into account for one of the time figures in the legend on the right. Then there's RPKI client, which doesn't provide version information, unfortunately, so it has a separate section. And then there are the unknown clients. The unknown clients actually exclude traffic that is coming from browsers. So it's software that appears to be connecting to the is connecting to repositories for some reason, but it's not immediately apparent what that reason is. So looking at this pessimistically, if all those RPKI client instances are version 7.0, which was the first release of RPKI client that had support for RRDP, then it could be as much as 50% of the validator population that's more than 12 months old. More optimistically, it's still 15 to 20%. So it's a substantial number of validators that are fairly old. And then there's the unknown clients to consider as well. So that needs more looking into. But in short, if we want to rely on attack objects in practice, then after the RP code updates are done, there needs to be a fairly concerted effort around getting people onto versions that support those objects. Okay, so next steps, obviously feedback would be good. once that feedback is addressed, we will move to updating the prototype code, and then we'll go from there. And that's it. Thanks.
All right, do we have any questions for Tom? Going once, going twice. Okay. Thank you, Tom. And next up is, I think, Tim. Or yes, Tim.
Still stand on the cross. All right. Can everybody hear me? Yeah, I hear myself, so probably yes.
Second while we arrange the slides.
Mhm.
Oh, good Lord. There we go.
Yeah? Well, speaking, oh, that helps. Okay, well, let's move on to the next slide. I'm going to tell a short story, at least that's the idea. I wanted to talk about hosted API service versus delegated. I wanted to talk about delegated CAs and repositories and then zoom in on a particular aspect of it. So jumping ahead a bit, I'll get there. I want to look at how do we migrate from one repository to another, actually. But let's start at the start. So the different models that we see today, by far the most common model is what is here in the top left, which is where you have a parent and a bunch of child CAs in one system provided by an RAR or an NIR usually, publishing all their content in a repository that is operated by that same organization, parent organization. Now, you can also run dedicated CAs, and then you have a choice of where you publish, at least sometimes you do. You can run your own repository. For certain, a number of RARs provide a service where a member of said RAR can publish at them. And we don't see this just yet, but it has been mentioned a few times in the past. The way the separation between the publication protocol and the delegation protocol, if you will, the provisioning protocol is organized, allowed for essentially third-party content providers to also provide a service where people could publish. So I remember people saying, let's just publish at Google, Amazon, Cloudflare, I don't know, whoever. I'm not picking any sides, but that was an idea behind it. Moving on. Next slide, please. Yep. So using a provided repository, well, what we have found is that in Brazil in particular, the RPKI uptake is all done through, well, people running their own system because they don't have an option to use a hosted service. So yeah, maybe if they did, they would use it. On the other hand, we see quite a lot of uptake, more than I personally expected. And I think that's mainly because if you don't have the concern about publishing, hosting a repository yourself, that takes away a lot of the pain of doing this. And especially it takes away a lot of the pain of, providing accurate, good uptime for HTTPS, but more importantly, maybe even for rsync, because organizations are not always ready to do that kind of thing. Whereas if you just run a CA on your side and it goes down for whatever reason, if you bring it up in time for it to republish before manifest and CRLs would expire, then it is a lot more forgiving than operating something 24/7. So I think this is really an enabler for people to do this kind of thing. Okay. Now, the question I wanted to get to is, suppose I'm doing this, and suppose I set up my own repository, for example, but now I want to move on to another repository. How do I go about that? Is that even possible? And we have actually implemented something. I think it needs improvement. And it's based on key roles, an existing standard that we do have. So next slide. I'll try to briefly discuss how key roles work. Maybe it go. How are we for time? Should I be quick or? Well, there's a lot of arrows here, and most of the arrows are actually missing. But it's to give an idea, right? Before any key role, the situation is you get a certificate from your parent, you publish a manifest and a CRL, and then you have a bunch of objects, ROAS, etc. And you may publish CA certificates for grandchildren. They're all in one repository, right? So then the next phase is that you would, next slide, please. You generate a new key pair, you ask for a new certificate, and you publish a manifest and a CRL, but nothing else. All the actual content is still under your old key. And then you enter a 24-hour staging period. Next slide. Then the time comes to activate your new key. And what happens then in the current key role algorithm process or thing is that you republish everything under your new key. So the ROAS, I mean, and delegated certificates for grandchildren, etc. And you remove them from the list of objects that you publish under your old key. So there we just have a manifest and a CRL left over. You can publish this in one go using a multi-element publication query. And this means that relying parties will also see it as one delta. So they will see this as an atomic operation, more or less. Well, more. This is true for RDP. If you set up rsync with the right incantations, this is also true for rsync. Yeah, and then finally, you will remove the old key. So you will ask the parent to revoke the certificate for your old key, and you can get rid of the manifest and the CRL. And this can be done immediately after the previous one. So it may not even be visible as two separate steps to everybody looking. Now, if we apply this to migrating repositories, what we've done, perhaps naively, is just, let's just use a new repository for the new key. And we follow the steps as though it were a normal key role. So we have a, here in the off-green color is the new repository. New key we created, new certificate we got, we publish a manifest and a CRL. We don't always wait 24 hours, to be honest, but we could. The next step is then invoked manually. And that's just like in the other system, we activate a new key, meaning that we publish everything in the new location. And this I think we should change. We also immediately remove everything from the old key, because that's how the normal key role works. Except in this case, you wouldn't see this as one atomic update, because fetches are happening in two different places. So you might see no objects, you might see both objects at the same time. Or you might just see this, which would be the happy case, of course. So a question is, and I think maybe asking the question is answering it, is that you probably want to keep objects in both locations for some time before you remove them in the old location. Next, please. Then, the final step is easy. Once that's all done, you remove the old, you ask for revocation of the old certificate, and you remove the objects associated with it. So that part should be relatively easy. One thing to realize as well, I don't think any of the relying party tools treat AIA other than informational. So the back pointer, let's say, the authority information access pointers, URIs that are included in objects, they point back to where a certificate is published. Now, if that changes here, then that might flag some things. Or maybe we need to look at the provisioning protocol 6492 that essentially has text. Okay, when a child asks a parent, like, what are my resource entitlements? Essentially, they get a response of, these are your entitled resources, this is a validity time that may be applicable. And by the way, this is the URI where your object might be published. Now, if that changes, maybe that should also trigger that CAs republish things. The downside of that is that you would see quite a lot of objects republished at that time, but I'm not sure that that is actually a problem. Last slide, I guess. Yeah. So the question would be really like, okay, I think we do need to support this kind of thing. I see at least one way that we could improve it, but the more important question that I would have to the group is, do you agree that we should perhaps document this and try to standardize how one would go about this, this process? And with that, I'm done.
Yes, please. Questions from anybody else? Sorry, this is Chris Morrow. As a regular person, yes, please standardize. Or at least document very well the migration process.
All right. Then I'll send one to the list soonish. Okay.
Next up, Alexander, who I think might be here. No? No, he's not here. Okay, well, hold on.
I think I'm
Alexander,
not
do you want?
there. Okay, I'll try to share my screen. Or I'll try to use my slides. So let me briefly check it. Okay. I will try to share my screen then because it's an outdated version of my slides. It's my fault. So if you can give me a chance to share my screen. Yes. Just a second.
Seems to be taking its sweet time there, Alexander. Do you want to? There you go.
Okay, I hope you can see it. So, once again, hello everyone. My name is Alexander Azimov, I'm for Yandex. And today I'm going to present a long-awaited update on ASP documents. Let's start with the profile document. So, in the version 7 and before, the ASP object was defined as customer IS with its provider list. It was expected that an ASP will create two objects, one for IPv4 policy and another one for IPv6 for policy. In the latest version, this schema was updated. Now ASP object carries not a list of providers, but a list of lists where each item contains a list of providers and may contain address family. As far as I understand, the idea was to give a way to create a single object for both IPv6 and IPv4 policies. It's true that a significant number of networks have the same set of providers in IPv4 and IPv6. And the process seems to be converging toward this state. Still, there are networks who have different policies in different address families. So it presumes the opportunity to have different policies in IPv4 and IPv6, while giving a way to put it all in one ASP object. In my view, the same goal may have been achieved with less changes, just making the address family optional. Still, even this lightweight change is getting into the same trap. At the level of router, we will have different representation of ASP record for different address families. I can expect the CLI support to navigate separately through the set of IPv4 and IPv6 records. At the level of RTR protocol, we'll also have different ASP PDU for IPv4 and IPv6. For me, the last ASP object update may break expected behavior by changing the object format during the processing and may also complicate debugging. Phone calls. I checked the thread this morning, and if I'm not mistaken, we have a perfect split. Although the new format have inter-op testing on its side. I have a nasty feeling that profile document and the new RTR document are running in different directions and running surprisingly fast. And if we don't converge, the community will know who to blame. So let's try to discuss this topic before jumping to the second part. How are we going to address this format change with 8210 bis in the RFC editor queue? Please advise. Maybe Ben want to go to the mic.
Ben Madison, work online. Look, I think I've probably said better. I think I've probably said everything that I need to on the mailing list already, but to reiterate, I think it's less work for the RP if there are fewer objects. I think that the overwhelmingly more common case is that networks have the same or very close to the same set of transits in both address families. And I think that I think one of the things that I tried to point out in a recent email is that I think that for an operator that's used to a user interface where it presents this kind of a mental model where the base assumption is that both address families are the same topologically, the day that operator then needs to go and read one of these objects to see what's actually being transmitted on the wire, I think it's much less surprising if it doesn't diverge too much from that mental model. I think the other thing to point out is that there's quite a lot that, there's been a lot of progress in new implementations over the last few weeks, and all of those are based on the version 8 profile. I think rolling that back is quite a lot of work for, a fair number of people. So I'm quite strongly in favor of the version 8 change.
I have a question for you. What are you suggesting to do with the RTR specification that is, fortunately or unfortunately, in the RFC queue? That at the moment, as far as I understand, was cooked for the previous version of the object. We can make it to work with the new one, but it will be may have a surprising specifics.
So I don't think that there's, certainly the formats in the RTR protocol and the ASN1 do diverge. I don't feel like that's a huge problem. I think that the overwhelming consideration for the RTR protocol is to make things as convenient as possible for routers to use it in policy decisions. And I think the existing format is, mostly fairly well suited to that. Whether we do this translation when it arrives at the router or when it's being processed by the RP, I don't feel like it's not a non-issue, but I think that the profile change can coexist with the existing RTR spec pretty comfortably.
But don't you think that, I'm sorry, I'm keeping you at the mic, but you are the person to blame for this quick progress. No kidding. My question is that, okay, we can split to, we can say, different policies at the level of API cache. I think that's what you are suggesting.
Yeah, that is what I'm suggesting.
But don't you think that the debugging can become really complicated when you will be using CLI at your router, asking for, please give me the information about what ASPs are for a selected address family, and after that, you will may have problems by building a corresponding ASP object in the distributed other database.
Yeah, so I think you're right, but I think it's inevitable that there's the kind of structure to use in kind of provisioning tools and config management tools is inevitably different from what is convenient for the router to store in its internal data structures. And so that translation has to happen somewhere. And my feeling is that probably the best place for that translation to happen is the RP, because compute is cheap there, and my feeling is it's the least surprising place for it to occur, because you're going from one protocol to another. And you're expecting there to be aggregation and things like taking unions of potentially multiple objects, and you're expecting there to be structural process going on there anyway. Did that make sense?
I still have a feeling, because I'm at the same time while you are keeping you at the mic, I'm reading the chat, and I still have a feeling that as a group of Sidrops, we are not converging, because I see that Randy Bush is still opposing this change, and he's authoring the RTR. I don't know how to make everybody happy about ASP object style. Maybe we should ask the chairs to be more involved in the process.
I think I should sit down and give other people a chance to offer their opinions then.
Thank you, Ben.
Ties de Kok, by the NCC. We have an internal implementation. Volume and height. Is it okay now? Yeah. Okay. Ties de Kok, by the NCC. We have an internal implementation of the version 8 profile, and I kind of want to elaborate here on why I prefer the version 7 profile in hindsight. In the end, the user interface that people will present may or may not align very closely to the objects that people create. It's all about making sure that the right objects are created and that there's no confusion in these objects themselves. And what we realized after implementing this was that we could create a lot of edge cases in the content of the version 8 profile, where the content semantically overlaps and you need to take a union there within the object. And covering this with a proper set of test objects was just very hard, or test cases. And that's the main reason I prefer the version 7 object, even though I really like the idea of having a single signed object per AS. But I'm just afraid that covering all these cases where V4, V6 overlap or not could lead to interesting edge case and implementations.
Okay, I'll take it as a point for the old version of SPA or SPA object.
Rüdiger Volk. I failed to really track the mailing list for a couple of months, and I'm sorry I did not raise my voice earlier. But look at the proposed change of the profile. Well, okay, a very superficial look at it says 07 looks much less complex than 08, straightforward. And I guess some of the complications that Thies was mentioning is related to the more complex data structure. On the other hand, my understanding is that actually the more complex data structure is not used in any significant way to express more functionality. Kind of, yes, there is a possibility to add a third and a fourth AFI, and there is the complexity that Thies was pointing to, and well, okay, kind of, just from that, I'm quite certainly not happy about moving to 08. In my first understanding, I was expecting that the work on 8210 bis would not have to be redone to fit the, which is adding more complexity to the whole system, because if you have different presentation of the in data structures for essentially the same content, kind of that means there is translation, there are translations necessary, and that's more complexity in the damned system than if you just can straight copy. I'm for the question whether we are actually delaying creation of the operational system. I would think, well, okay, if a rerun of 8210 bis is required, I would strictly oppose the idea. Moving on 08, I'm very unhappy about added complexity. I don't see real good reason for it. And for those who are saying, well, okay, lower complexity for the user interface, which actually is another presentation of the same content. Well, okay. 10 years back, we would have had a situation where the AFIs usually would not align very well. And if they align at this point in time, this does not mean that it's going to stay this way. So kind of the argument, well, okay, we are making people happier for just this time. This is just a temporary argument, and I don't really buy it. But kind of my highest concern is that I do not want to see development of the operational system being delayed. But complexity is going to have cost and should be avoided and not unnecessarily introduced.
Randy Bush, IIJ Arcus. First, the of the GUI to the user arbitrary for and or
Randy, your audio is the worst form of robot.
Randy, you have a really bad voice synthesizer.
Do you want to try one more time? Okay. Sorry, Randy. Okay, you pop back into the mic queue when you're ready. But I think Tim, and then Warren, and then Ben.
Yeah, so, hi, yeah, Tim Renzels, Anala Labs. I guess I'm partly to blame for all of this, because I think this discussion started last year, sometime November, December. I think it started with a desire to use up less space, even. And this AFI limit actually came to be as an additional thought in that process. So the first proposal that I did then was that we would have a single AS object with 2 distinct lists for each address family. Then the address family limit was introduced as a way to compress that even further. And then the idea came to be that this might actually reflect better what people want to do. All in all, this can express exactly the same kind of data as, you can express now with the 07 protocol. So in that sense, it is really a matter of preference, and I think it's something that we can, keep on discussing until, well, how did they say it? The cows come home. And I want to second what Rudiger said. I would really hate for that discussion to delay deployment and experience with ASPA. So if it comes to that, then I am quite willing to change my implementation to follow whatever profile is in the end acceptable. So that's what I wanted to have said. To comment on the data format versus 8210 bis, I think there's prior art there. I mean, if you look at ROAS, you can have multiple prefixes in a single ROA object. You don't get this structure in your router. You actually have to validate multiple ROA objects and make a union of everything, and then that is what gets sent to the router. And similarly, whatever the profile is, this translation can happen at different levels. It can happen in the RP as it is currently done for ROAS already. And yeah, it can also happen in the UI, where obviously I can present users with an interface that allows them to provide a common list, and then my software can work out how to make 2 distinct lists of that. It's trivial for me as well to do that. So yeah, I don't know if any of this is bringing it closer to a solution, but I guess my main message is that, I just want this to work.
Try for Randy.
One, two, three, 1, 2, 3.
Okay,
Any
we can hear
better?
you. Good. Better.
Oh, is that a bug or a feature? First of all, what's presented to the user in the GUI is arbitrary. In either of these schemes, you can present separate or joined in the GUI. Makes no difference. What is on the wire is almost never seen by the operator. A few X509 geeks actually look to the garbage on the wire. When I want to see what's being published, I don't look in the repository. I don't look on the wire. I look in my router, because that's where the rubber meets the road. Okay. What is in the router is going to separate V4 and V6, because that's what happens in routers. Thank you, Steve Deering and Bob Hinden. The 8210 bis change, while technically or procedurally possible, is not what we want to do, because we want to keep the burden of any hacks north of the router. The whole purpose of 8210 is to get the load, minimize the load on the router, and the router choose up 6 and 4 separately. Lastly, like it or not, V4 and V6 topologies are not congruent. We wish they were. We've wished they were for 20 years. They're not. Yet this is especially seen in Asia, but it occurs here today. Does any operator on in this meeting who actually uses multi-protocol BGP so that they have V4 and V6 in a single configured session with their peer? Or is it like all the rest of us that we have separate sessions for V4 and V6? It's not pretty. It's just reality. Thank you.
Thank you. And Warren Kumari relaying a comment from Rob Austin. Still more? Yeah, I can't read and look at the same time. So thank you, Rudiger. I'm extremely uncomfortable with requiring transit on different AFIs to be in the same path when you damn well know that sometimes they are not. Maybe I misunderstood the question. Kayora is looking confused. I can read that again. I am extremely uncomfortable with requiring transit on different AFIs to be on the same path when we damn well know that sometimes they are not. Maybe I misunderstood the question.
I'm not getting it. If somebody can help me, please go ahead.
It sounds like a lot of this conversation should be on the mailing list. Probably it would be easier to reason about it that way. Also, just remember, please, of course, code of conduct on the mailing list applies. Ben?
Just the last thing, I mean, mostly in response to what Rudiger was saying is, better? Yeah. I don't think that we're arguing here about more or less complexity in the system as a whole. I think we're mostly talking about where that complexity should be dealt with. I don't think that any of this need to be a showstopper, and my priority in all of this really is to try and get some running code out the door and into production sooner rather than later, because I think this is a technology that we have wanted for a long time, and we should prioritize trying to get it deployable as soon as possible rather than arguing about the details.
Okay, there's still three people in. Alexander, go.
There are three people in the queue. Okay.
There's two. Warren needs to take his hand down if he's not going to say something.
I see. Sorry.
Same for Tim. Nope. Okay, Tim's all done. Good. It's on you, Alex. Go.
So I'm not the person to announce that we have reached consensus here. Hopefully, I believe that getting there in the form of 07 can simplify the process. If I want to move faster, maybe it's the best way, especially taking into account the comments of one of the implementers who was saying that there are a huge amount of tests and the format is getting complicated. I am not one of the implementers, so I can't comment further, but my personal view is that 07 is simple, and so it can fly faster than 08. Okay, but nevertheless, let's keep this discussion in the mail at least. I will try to summarize it after the meeting ends, and as I have only 15 minutes left, let's move forward to the second document. And it's about verification. And it also suffered a lot of changes. The more changes were devoted to generalization upstream and downstream procedures. For this purpose, we defined new index types. First one is invalid index, which is a minimal index for which IS with index I have not authorized next IS to be its provider. We also defined a reversed invalid index that is calculated the same way, but for the reverse IS path. Let's see how these indexes help to detect route leaks. For prefixes that are received by peer, provider, route server client, the rule is very simple. The invalid index defines the length of the first upstream segment, and in the case of a correct path, it should be equal to the length of AS path. From this, we can get a simple rule. If invalid index is less than the length of AS path, it's a route leak. It's important to note that leak detection at IX by route server and route server client is not a special case anymore. In the profile document, we added that if a route server is not transparent, it must be added in the list of providers. With this, all parties at the IX are entitled to use upstream verification procedure that we discussed just above. Now, detection of route leaks that are coming from provider. The correct downstream path may contain the upstream segment and downstream segment. The invalid and reverse invalid indexes define their length, respectively. So, to detect route leak, we need to check that the sum of invalid indexes is less than highest path length. For me, it looks fairly simple. Now, let's discuss the unknowns. In the previous versions of the document, the unknown path was defined as the path that has a common system that don't have ASP record. With comments from Sriram and Yaro, this definition was transformed to the next one. The unknown path is the path that may have been leaked. And it proved out that the detection of unknown paths is in this definition is very similar to the detection of route leaks. We again define two indexes. The unknown index defines the first IS in the upstream segment that doesn't have ASP record. So it's not invalid, it just doesn't exist. We also define a reverse unknown index for the reverse IS path. So the path may be leaked if there is enough space for leak to happen. In case of routes received by providers, peers, or at IX, it means that unknown index should be less than highest path length. And a very similar familiar equation we get for routes received from providers. If the sum of unknown indexes is less than highest path length, we can't guarantee that the prefix was not leaked. Now, the overall rules for provider, peers, and IX. If the invalid index is less than highest path length, it's a route leak. If the unknown index is less than highest path length, it's unknown. Otherwise, it's valid. For the downstream, it's nearly the same thing. So, if the sum of invalid indexes is less than highest path length, it's invalid. If the sum of unknown indexes is less than highest path length, it's unknown. Otherwise, what surprise, it's valid. So, there is an ongoing discussion how we should protest IS sets. It seems that we are converging to marking routes with IS sets as invalid. To make it consistent, this should be applied without reference where IS set is placed, in the beginning or in the middle of the path. The implementation of PSP logic with corresponding unit tests, the current implementation, you can find at the GitHub. So what I need input on these questions. I need volunteers that want to read the document. I will need volunteers who want to code the ASP logic to check the specification. The mic is yours.
Chris, I go. Can folks hear me? This is Sri Ram.
I can hear you.
Okay. Thank you for the nice presentation, Alexander. Can you please go to slide 9?
Slide 9.
Yep.
This one.
Right. So just want to make a comment that when you have a provider that has no providers like the tier 1, we have said in the draft that they will register an AS0 ASPA. That is fine. I think we have also said that an IX or a route server AS will also register an AS0 ASPA. That's also fine. You didn't mention it here, so I thought it's worthwhile mentioning those. But one more, a little bit more tricky thing that not in the draft yet, but I think we perhaps should discuss that between you and me at least, and include that in the draft. And that is about if you have a transit provider who happens to be present at a RS at an RS as a client. So it's a tier 1 transit provider and happens to be present as at an RS as an RS client. In that case, they should register an ASPA with the RSAS as a provider, just like any other RS client. I think that's something that we still need to include in the draft, and wondering if you agree with that.
I wonder why we should emphasize this scenario in the document, because the document just says if you are connected to a non-transparent IX, you should include its outbound system number in your set of providers. That's all. It doesn't matter if you are tier 1 or not.
Okay, good. Yeah, so tier 1 should not be misled into thinking that they just need to register an AS0 ASPA and they are done. They should be sensitive that if they are present at a route server as a client, they should definitely include the route server AS in the ASPA. If you think the draft is clear about that, it's okay. If not, we can talk about it and perhaps put in a word to be sure that people understand that.
If you find that some wording is missing in this document, please send them back. I'm trying to do my best to carefully read all the comments and push them into the document.
Sure, I'll help you. And just a little mention of the use of the upstream for the route server client. I think I have some examples where that doesn't seem to work correctly. But again, that is too complex to discuss here. We will discuss it between yourself and myself, and then we can take it to the mailing list if needed. I just want to mention that. Thank you.
Okay, thank you.
If it's too complex, maybe you should, oh, I'm sorry, Randy Bush, IJ Narcus. If it's too complex, maybe you should take that as a warning. Not exchange points that put their AS in the path are against spec. Do not make complexity in 93 other places because of it. It's not worth it, it's uninteresting, and it just creates more complexity. Reduce complexity. Please, reduce complexity.
Randy, thank you very much for the comment. I'm doing my best. So about the non-transparent access, as far as I remember, there are 2 phrases devoted to that. And unfortunately, I need to stress that they are in the wild. The last time I checked, I've seen 1 IX that my network is using that was present in the path. And I was also surprised to see that Hong Kong Internet Exchange is still there. I was not looking for more examples.
then medicine work online. So it's certainly true that a transit-free network at a non-transparent IX root server would need to include that root server as one of its providers. But that is such a vanishingly unlikely scenario to actually come up in the real world. I really wouldn't call it out explicitly and waste prose on it. I think that in the interests of simplicity, what the document should do is emphasize the fact that a non-transparent internet exchange root server is just a transit provider. It just happens to forward on MAC addresses and not IP headers. But in any way that this document cares about, it is just a transit provider and should be treated indistinguishably from that case.
Thank you for your comment. If we are digging into the details, there is only one thing that is different if we are speaking about route server behavior, because if it is transparent, as the specification suggests, we are not checking that the neighbor autonomous system is equal to the last autonomous system in the path. This is the only exception in the X proxy. In all our other cases, it's just the same. So I think we are on the same page here.
This is Sriram again. I just want to make a quick comment that it actually turns out that the non-transparent IX is less complex than the transparent IX, but both of them can be taken care of in the draft without too much complexity. The only other comment is that it appears to me that if AS, even if the route server is transparent, it may be worthwhile to register an ASPA by the client, including even the transparent IX in the ASPA. That's something again that we need to think about that carefully, and there is I think utility for that.
According to the goal that we're trying to solve, the route detection, there is no need to register to register transparent IXs.
Yeah,
the issue is only with the.
Go ahead.
It's not harmful to register them. But still, I don't think that the specification should make such suggestions.
Yeah, yeah. Again, like in my mind, it helps to have the algorithm at the route server client kind of unified.
Hey, Sriram.
Yeah.
Hey, we're gonna get kicked out of the room here, so I think all this has to end up on the list. So my suggestion is that you start writing to the list right now.
Sure. Yeah, thank you.
And Sasha, thank you very much for the presentation. You probably also have some stuff to write to the list.
Yeah.
See everybody in the next place we're going to be, which I think is London, unless we need to have an interim meeting to talk about stuff. And if we do, you should definitely put that on the list. Thank you.
Thank you all. Bye-bye.